Thanks for the invite. It's been a couple of symposiums I've been to about things that suck, so I don't know if that really says a whole lot about my career or that I happen to might be the life of an aphid biologist, I guess. So I'm going to spend a little bit of time talking about the mobile technology part and also about monitoring. And you think about the vast amount of information that is already being thrown at all of us as researchers, as extension specialists, but also our growers. The sheer amount of information that needs to be managed is quite overwhelming when you think about it. Even though it's only been here a couple years, there's a significant amount of momentum, and where does this information go? So hopefully I'll give you a little bit of maybe insight as far as how we've tackled this with other cropping systems and a particular program we're putting together called MyFields. So why mobile technology? Why is that even important? Without even raising your hand, I'm guessing most people in this room, maybe 95% of you, have some type of mobile device walking around with basically a supercomputer in your pocket. Not only that, but it's capable of GPS, accelerometer, camera, Bluetooth, Wi-Fi, significant number of gadgets that are attached to it, mainly to change the way in which we interact with our environment. I'm not going to do it now, but usually I do a nice little selfie. We record our experiences. We look at the world around us through literally a different lens. A lot of that has to do with, again, the quality of the cameras that are increasing, the size of the phone decreases and then increases. The screen resolution is great, but really the technology has advanced. And when we really think about where we've come from, it doesn't take a lot of computing power to go great places, but at the same time, we have all this computing power. At least the case study I'm going to talk about soybean aphid is that we haven't really, another invasive in a field cropping system, we haven't really tapped into the potential of mobile technologies and digital delivery of that information to our stakeholders. And that's already been close to 15 years since it's been introduced. So again, with the sugarcane aphid being a problem over the last few years, expecting it to be a problem over the next few years, how do we leverage some of these technologies to better suit our stakeholders? Not only that, but the external devices are getting better. So here's a wireless microscope, not very much, 150 bucks, getting some close-up of a hawthorn leaf. I'm not a pathologist, but maybe I'll send this picture to a buddy of mine who is, and get an ID for me. Okay? This is the way in which we live in a mobile world, in which we are seeing things quite different. And not only that, it's making it easier for us to take these to the field. Here's a Mophie with a full charge on it. If that's not enough, here's one that has 2.5 charges to keep your phone going the entire day, and that's using full GPS the entire day. So the excuse that this doesn't work all day, again, technology comes to the rescue. And if you're using this to take pictures and you want to make sure you're staying up to date on text messages, you could get that on your watch. Right? So this is, again, wearable technology. The way in which we interact with our environment is constantly changing. The only thing it can't do, and probably had too many of these this morning, was create a cup of coffee, right? But that's just a matter of time. It's just a matter, this is your mantra through the entire talk is it's just a matter of time. Or it's already there and we just haven't even leveraged it yet. That's kind of the point of this talk. Right? FLIR has a nice little you can create heat maps. What we do with insects when they're exotherms, don't know, but think about photospectrometer. Again, another attachment that we put on here. Maybe looking at normalized difference vegetation indices, looking at what the quality of the crop is. Okay? All those things that, again, external devices, things that go onto those mobile computers that are around with us constantly. So how does this fit with IPM? Well, let's just start here. Okay? Ready, count. I'll give you a minute. Why in the world we want to leverage digital technology? Again, working with soybean aphid through my PhD, part of my postdoc with Dave Ragsdale, counted probably billions of these over the last 15 years. Okay? Okay, beat you the punchline, 966 aphids, right? How many were close? Anybody? Nobody else? Nobody wants to say how off they were? Okay. But why does this matter? Well, counts matter. We heard often that, the threshold of whether it's 50, 150, whatever number insert here, that number matters for a decision. It's the foundation for ETs, EILs, which then go into sampling plans that can be economically based. This feeds into population dynamics, knowing where the population is now, where is it going to be in a week, how does host plant resistance affect that, right? Biocontrol agents, how are those affecting population growth? Numbers do matter. So it was really after probably the 500 millionth aphid that I was thinking about this, going, there's got to be an easier way of doing this. The technology exists. Maybe we can be using that phone that I'm answering emails with to be doing the work for me to come up with a better count. So kind of talking a little bit about that here over the next few slides of what we did. And part of that was making paperless speed scouting, which is a concept that Dr. Aaron Hodson at Iowa State did while working with Regs out of Minnesota. This whole plant tally threshold, again, we can count to 40. We can see what 40 looks like. That's a yes, no, presence, absence type sampling, which will eventually move into MyFields. And the concept is, the main point is that people are using this. They're still using this to make management decisions. The trick, though, is that 40 is going to turn into something, and we're always trying to be more conservative with our insecticide applications. Not only that, but how do we start leveraging the technology, give them easy access to these sampling methods? So again, not having to go figure out where to find it and relying on the easier solution, which is just a spray. How do we do that? Mobile technology, possibly to the rescue. Again, we have the computing power, and maybe we can then integrate these types of decisions, these little snapshots, into more sophisticated algorithms for predicting what's going to happen within that particular crop when it comes to economic yield loss. So what we did, I'm just going to briefly go over this, is basically took camera, set distance, not necessarily a set distance from an aphid-infested leaf, used lots of different devices, very cheap camera up to a very good Canon camera with about 100 millimeter macro lens, and then an iPhone. I'm not showing you all that data, but okay, trial and error coming to what we have as our kind of finalized algorithm that we've validated here this last year. And just kind of give you, again, a series of pictures of what basically we're doing with that particular algorithm. So we process that image. First we take it, then we grayscale it, remove the noise, contrast enhancement, apply some additional filters and fills, segmentation. Then we get a final images with no ranges, but realize some of these little specks are actually the same color of the soybean leaf, so saying that an aphid has to be a certain size, and voila, you get a number of 845. Okay, and so what I'm going to show you is that number is actually pretty consistent across densities. It's doing a pretty good job. But when it comes to an untrained aphid counter, we don't do as good a job throughout the entire range of aphid densities that we could find on a particular leaflet. Does that sound like a particular problem when it comes to sugarcane aphid? Maybe not, but again, people estimating those numbers that are not real well trained to do it, depends on how well they do it, depends on the density. So here's an overlaid image, so I'm showing you that does actually a pretty good job of finding those aphids on a leaf. Not really, we had the scale in there originally, but it doesn't necessarily need a scale, it just needs a pretty constant background. So I took this to my entomology class, and I made them count aphids. This does not really affect my teaching evaluation scores. However, we did subject them to about 178 images where they had to guess how many aphids were on that particular leaf. But first we calibrated their aphid eye, gave them a range in densities from low to high, something that's around the tally threshold, something around 150, and then above the EIL. And then we had them record the number they found, gave them the set of time it took them to get there. But I'm not showing that data today. The data I am showing is basically gave them 5 seconds per leaflet to go through the 178 leaves to give me an actual number, what they think is on that particular leaflet. So what I wanted to do is contrast this with basically what we're getting, hopefully with a mobile-based application. How well are we doing? So to show you how well the particular application is doing, didn't look so hot until we cropped it. And this I'll show you why. And so we thought we had a pretty consistent background, but there was enough a little variation in enough a little bit of texture in the background to cause quite a bit of these red pixels showing as aphids. So once we cropped it, we actually did a pretty good job of getting close to the actual. And over the course of the range in densities, we have up to about 1,000 aphids per leaflet. We're estimating with about 92% accuracy. So still underestimating, maybe by 20%, but for me that just becomes a correction factor that, again, the grower wouldn't have to do because it's already built into the mobile device. Now let's see how the students did, the 41 students that have never counted soybean aphids before. So I split these up actually to something that's more meaningful for management decisions. So we have the TT, which is tally threshold to economic threshold, which is 250, so that's 40 to 250 aphids. And then I broke it up into anything above economic threshold to the EIL. So basically, they do really well up until the tally threshold, which is good for us being those that have been using and promoting the speed scouting for soybean aphid management. But when it comes to densities above that, you might as well flip a coin. And then anything above the economic threshold, they actually underestimating the populations by 70%, which to me was quite interesting. Usually because most of my students are agronomy students who have sometimes the mentality of if I see one aphid, that's the threshold, I'm going to spray. But in most cases, when you give them a leaflet with no number of aphids on it, they tend to underestimate those. Again, not only that, but the amount of variability, and I'm not showing that here, the amount of variability for each of those leaflets increases, for every 10-fold increase in aphids, there's a 103-fold increase in variance, the amount of variability around those estimates. And that's for a small little soybean leaflet. So I think there's going to be some challenges in taking this particular information and bringing this into leaves within sorghum, which are, again, much more area to cover as far as estimating the number of particular aphids on a leaf. Again, we haven't done any of that work. That's something that we're interested in doing if we get aphids again in August this year, which we did in Kansas. But just kind of give you a little bit of where do we go with this. We can estimate the number. It's on a leaflet basis, but we can actually plug this into some algorithms we developed back in 2008 and validated in 2010, and to use these to estimate whole plant counts using a subset of samples. So this might be another approach to sugarcane aphid where, again, maybe not examine the entire leaf, understanding the change in distribution of that aphid over time within the canopy, and then maybe using that to predict what's going on over the entire plant, and hopefully taking a snapshot of it. But that snapshot of this particular aphid is a little different than soybean aphid. So again, we do have our work cut out for us. But I'm going to transition into sampling as one part, coming up with that number as one part. But monitoring for this thing is kind of a different beast. Soybean aphid is migratory. For us, Kansas, we're kind of in the middle, not kind of, we are in the middle of the country. So for us, soybean aphid, it migrates in. For sugarcane aphid, migrates in. So we're usually on the tail end of most of these infestations. But for monitoring, again, if my app is working, I know what's happening in my farm, but I might not necessarily know what's happening anywhere else. That is an issue that not only is a problem for us dealing with sugarcane aphid, it's been a problem for us dealing with that in soybean aphid as well. Is knowing where these populations are early enough, knowing how much wind and other environmental factors move aphids around, knowing where these aphids are really affects when we sample and how long we sample for. Again, a team of people are emailing bowling, right? So this is the current snapshot of how this process is done. So there's a significant amount of work that goes into that map, but it's now relying on one person to add all that data in, get those maps out to people. Again, I'm sure it's well more than 30 emails by the time everything's said and done, and that gets into maps, again, when one person has time to kind of consolidate all that data and get that out to somebody. What I want to focus on, though, is let's think about this in the context of a social network. Whether it's Facebook or Twitter, it doesn't matter at this point. Just think about what a social network could do in this particular case. And I'm going to use our little case study of Sedgwick County as a prime example. Okay, so Scott Armstrong has credit for finding first sugarcane aphid in Kansas. And if he's listening to this, it's possible that he brought it with him. I'm not saying that he did. I'm really not, Scott. I'm not saying he did. But again, we know that it was established in Sumner County just below it, but it did move. But how did we find that out? My lab was looking at 17 locations for cornea worms, so we were also double duty trying to look for this aphid. Not a single sighting until after a focus team meeting working with county agents. They were talking about how they're using social media. I got back on the bandwagon with Twitter. I started following Zac Simon from Sedgwick County, who retweeted Nathan Cole's pictures that he found in Sumner County. We went down the next day and ended up confirming this in 9 additional fields in Sedgwick County. This grower even helped us set up some field cages because he was really interested in the work that we wanted to, which was looking at freeze mortality. That was because we were expecting some freezes coming up in the next few days. We wanted to know how much freeze was going to be caused by this. So again, we tweeted this out, then looking at, hey, we got down to 22 degrees and all the aphids that we had died. It's interesting information, but for me, what's most interesting is, I emailed bowling, we got this information out. This was posted on the 10th. I tweeted this on the 10th, and this went out to had over 1,000 views. Okay, that's great, but I only have 157 followers. Right, so how does that happen? It's a social network. You see it's a little washed out, but this little thing down in the corner where it says 4, that was retweeted by 4 other people that follow me to see my updates, right? This is how that information disseminates to those that actually care about whether or not sugarcane aphid is in their particular county. Again, connecting with a county agent I hadn't connected with before, who retweeted what a grower was seeing, and me in the next day finding that in a county. Now think about all those existing relationships that are already going on out there, yet we're not capturing that particular event using social media. A lot of it, there's a stigma around Twitter and Facebook. That's great, but the concept still works. That's the take-home message. The concept still works. We just need something, in my opinion, that's really more grower-friendly, which we call MyFields, right? This is taking a container information around a field that we manage, and what information do we really need to manage that field. That's the grower's cap. I can say this out loud, they don't care about entomology until it's a problem. All of us here care about entomology all the time because we're geeks, right? That's what we do. We live for bugs. But they only think about this when they're standing in their field and there's a problem. So we need to be a little bit more proactive about this. And the way we're doing this with MyFields is we call asymmetrical data flow, which is really the Web 2.0. So you have a stakeholder, they tell us who they are, where they are, when they are. Who they are is one time create an account, when and where is all time stamped and geo-referenced, right? We don't even need to ask them that information again. And then we can push a bunch of information back to them that's specific to those 3 pieces. The cool thing is, you add one more, and the amount of data that goes back to them that's specific to their needs increases, not exponentially, but it becomes so much more specific to what their need is. Right? This is the beauty of, this is social media. This is, believe it or not, Facebook. Right? You like a few friends, you get information just about those friends, not the 1 billion users who are using Facebook. Right? So here's the MyFields experience. I'm going to go through this. I'm not going to spend a lot of time on each one, mainly because you all get a free account just for showing up today, or any day, really. It's a free account. You can sign up today. You can look through here. What I'm going to show you, though, is what Bob's experience is coming up on sugarcane aphid. Okay? So I'm going to kind of go through these a little bit quickly, but again, you can go to myfields.info/pest/sugarcane-aphid to see more about just sugarcane aphid. But for right now, I'm just going to show you what Bob's experience is. Again, he doesn't need to be signed in to see some of these tools because we don't necessarily need to know who you are and when you are. We don't need that information. But if you do sign in or sign up as Bob, right, we can tell us who he is, who he works for, what state, what information Bob is interested in, what county. Again, if we want to push alerts to Bob, having preferences like this becomes very valuable. Again, tell us a little bit more, we'll give you a lot more back. Not only that, but you see field guide peeking up. And he's actually got a customized field guide based on all the pest profiles that we've offered him. So he's gone through and customized those pest profiles. And he's in a soybean field. Bean leaf beetle's a problem. Oh yeah, there's a management guide for it, because I couldn't remember what chemical controls are currently available to me in 2015 from the insect management guide that KSRE offers. And I go out and manage this. And right next door, I go to my sorghum field. And I see something, I don't know what it is. It's an aphid that doesn't look like anything else I've seen. I go to my resources, I select my crop. I know it's an aphid based on my experience. I know it's not green bug, so I'm seeing some of these key features that make me say it's not green bug. I dig a little deeper, read the pest description. I can actually click on that link to find out more. Or I want to see a little bit more about management guides. Is this something I need to worry about? If I click on the Kansas guide, it tells me some things about it in Kansas, but mostly not alarming. There's not a lot to know about it. But in Texas, if I'm Bob and my user experience is in Texas, that's a whole different story. There are other things I need to be concerned about, much of which has been covered up to this point, much of which will be covered after this point, and for the next X number of years, right? Soybean aphid has been a problem for 15. There's a good chance this will be a problem for a while until we really get some good solutions available to growers. But again, information about sampling methods, first detection, and submit a sample. So I didn't have to go out and look for a sampling form or tell somebody about it. I can actually click on the sample form, confirm that, yes, this is the one that I'm looking at, grabs my location. I can add Fieldside if I want to. I don't have to. So if I'm an agent, I can add some type of reference that I know how to get back to later, how to reference it later. And I just say yes or no, it's here, yes or no. Now the cool thing is that as the sampling methods and protocols and ETs, EILs, all that gets more complicated, sophisticated, that's actually economically based, this form changes, yet that link for that grower does not. So as soon as they put it in their pest profile, their management guide, Sugarcane aphid is there, there's a sampling form for it, and we decide when to push the new one to them. They don't have to go and find it. Okay? This is the way the web is built now. Extension is way over here. Not because that's where they want to be, it's because funding is crashing. FTEs per number of acres per state is crashing. Okay? And our relevance is going outside of us because in most cases the information is taken from our sites freely and better distributed to our stakeholders for a price. So what we need to do is find a more efficient way, in my opinion, of giving this information to our stakeholders. Again, then we can finish up the sampler, submit that to somebody who cares. Again, it depends on who you are. If you're just a grower, that's not going to go into a major database until it's verified. But if you're an agent, if you're somebody that we trust, data can be verified, that information can go somewhere else, it can be mapped. Does that sound familiar? We don't have to email bowling anymore. As soon as that information is available, it's in a map, as long as we trust that data source. That becomes our conversation. Not necessarily today, maybe for the roundtable. Or we can then plant this field, and we get information about the crop type is sorghum, but maybe I get more variety information about this, and it's a resistant variety. Or how do I get a resistant variety? So again, it goes beyond just, I'm submitting you a sample that sugarcane aphid is here. Now, how do I manage it? That's the MyFields philosophy. Is how do I best support that particular crop, where and when it is? Not just about reporting the pest. It's important, okay, but we have to think about our different use cases. And where we're going is really the more interesting piece, and I wish I could show that with you, but this is really over the next couple months. It's really more about the alerts and notifications. So you tell us what counties you're in and where your fields are located. You haven't seen sugarcane aphid, but it's reported to be moving in your area, or there was a weather event potentially pushing this into your area. You get notified. You just click on the notification. It tells you sugarcane aphid could be in your area, and here's the sampling form that's used to tell somebody about it. Okay, think about how they would have to do that right now. First, they'd have to care. Being completely honest, first they'd have to care. Second, they'd have to then go search our entomology site, and good luck. Right? Maybe Google it and come up with 40 different sites that mean nothing to them where they are. This is the fundamental change that we're talking about. So where does this leave us? Well, we're working with Joe LaForce and the Bugwood group on getting that really simple sampling form of yes and no with the right permissions as a web service into EdMaps, because they have the capacity to do this, and they have a lot more apps than we do, especially native, that can just do the reporting. What we're focusing on is really more the management piece that goes along with the reporting, which we've learned from our stakeholders is a lot more important than just showing us what's on a map. It's what do we do about it once we see it on a map? And so this could be sugarcane aphid, but this could be any insect that comes along, right? Anything that we want to report on. The cool thing, and these are really question marks, right? This is ongoing, and these are really more conceptual, working with the Great Plains Diagnostic Network. They get samples, they get digital images in, those go into the basics. Yeah, we've got that, that's an established species, goes into a database that doesn't get used. We're working with the Crop Improvement Association that do reports, inspection reports on certified fields, that sit in a filing cabinet. Right? We're thinking about ways of taking that data, bringing it into a centralized database, and then everybody gets to use that data. Because we've talked about verification, we've talked about the use cases. One app might be better for one use case than another. Permissions, who gets to share what, right? Those become really big talking points. But again, once we figure that out, that's all sitting in the background. Okay, then we trust what the data we see, shared data, and then also protecting the user's data. That become really the big things that we want to think about as far as systems go. So that, in a nutshell, is where we are with MyFields. I'd be happy to answer any questions if we have time. If not, I'll be around for the round table. So thank you.